Our first speaker is Mr. Amit Rastogi. He happens to hold the position of Executive Vice President and Chief Technology Officer of Coromandel International Limited. He is a BTech from IIT Kanpur and PhD degree from the State University at New York at Buffalo, USA, both in chemical engineering. He was also selected for the Fulbright Fellowship at Carnegie Mellon University in 2010. He has been granted 10 Indian patents. In his current role in Coromandel, he's coordinating work of 6 R&D centers which are responsible for developing novel products and technologies for plant nutrition and protection. Also supporting the growth projects in new areas such as specialty chemicals. Ladies and gentlemen, Mr. Amit Rastogi.
My fellow speakers on the dais, distinguished delegates at the BASAI event, I would like to thank BASAI for giving me an opportunity to speak today on the topic Neem and Botanicals as biological agri-inputs. I work for Coromandel International Limited, which is one of the leading manufacturers and marketers of neem-based pesticides. My talk today will not be focused on neem, rather I'll be focusing on botanical pesticides as a group and the benefits it can offer and what we would need to do to make it a serious alternative to synthetic pesticides. So the structure of my talk will be as follows. I'll first briefly touch upon the need for alternatives to synthetic pesticides, then give a brief description of botanical pesticides, the potential of botanical pesticides in terms of the bioactive content, the mode of action, and how it can offer an alternative to chemical pesticides. Then move on to the global scenario with respect to botanical pesticides. What is the kind of a global market that we have for these kinds of pesticides? And then come to the Indian scenario. The Indian scenario, I would like to briefly touch upon the current registration procedures and the regulation environment for these kinds of botanicals. And what are the challenges with respect to the scale-up and the commercial acceptance of botanicals in India? And I finally like to conclude with the suggested actions for increasing the market share for botanicals in India. Now, when the negative impacts of synthetic pesticides are well known, and some of them are listed here. So we have human illnesses due to exposure or ingestion. You have harm to non-target organisms. We have pesticide residues in food and feed. We have pest resistance and resurgence, accumulation of contaminants in soil and water, an adverse effect on biodiversity, partly because of the slow biodegradability of these chemical pesticides. So clearly there is a need to find an alternative to chemical pesticides, and this was also emphasized by many of the speakers who came before me. When I think the gentleman before me who spoke about the European scenario mentioned about the target which Europe has set for itself to reduce chemical pesticides to 50% of the current level. And I think that's probably motivated by many of the concerns which are listed here. Now, what are the alternatives to to chemical pesticides? So obviously biopesticides are an alternative to chemical pesticides. And when you talk of biopesticides, we have different groups. We have the microbials, we have the biochemicals, and we have the plant incorporated. So, and within the biochemicals, we have the botanicals and the semiochemicals. Within that, we have the pheromones and the allelochemicals. So my talk today will be entirely focused on botanicals. So I'll not be talking about microbials, I'll not be talking about semiochemicals, and I'll not be talking about plant incorporated protectorants, which was basically the focus of the talk by Dr. Payental when he talked about the GM modified mustard. So my talk today will be how botanicals can offer an alternative to chemical pesticides. So what are botanicals? Botanical pesticides are primarily secondary metabolites which offer the plant, or these are basically phytochemicals which offer the plant protection against adverse environmental factors. And these are chemicals produced by the plants as derivatives of primary metabolites. And they serve the purpose of a defense mechanism. They can act as repellents, they can attractants, antifeedants, and growth inhibitors. And they can protect the plants from insects and also from parasites and diseases. Now, these metabolites, when extracted and formulated, they can be sold as botanical pesticides. The botanical pesticides offer the following benefits over the chemical or synthetic pesticides. They have low toxicity to mammals. They're relatively safe to use. They cause, again, less environmental harm or pollution. They don't cause harm to non-target organisms. They are very specific, very high specificity, low risk of pest resistance, and a large range of molecules through biosynthesis. The last point I would like just to emphasize a little bit. Now, the range of biomolecules or the range of secondary metabolites which can be produced in plants is more than 50,000, maybe 60, 70,000. And this kind of range of molecules will be very difficult to synthesize through chemical synthesis. So this is actually a very interesting opportunity because it's a vast range of molecules available for usage as biopesticides. Now, what are the range of molecules? I had mentioned about 50 to 60,000 molecules being available as secondary metabolites. So these secondary metabolites can be categorized in some 6 or 7 groups. So some of the groups are alkaloids, phenolics, terpenoids, terpenes, lipids, organosulfurs. And the mode of action of biopesticides or botanical pesticides, it basically falls into 4 types. They can act as repellents, antifeedants, toxicity, and insect growth regulation. By repellents, we mean basically these botanical pesticides, they repel insects from a distance and the insects are turned away from the plants. Antifeedants basically, and the repellents are basically, a lot of essential oils are used as repellents. So you can have oils of aniseed, peppermint, lemongrass oil, which can be used as repellents. Antifeedants are basically what reduce the consumption by the insects. And these antifeedants are basically azadirachtin and neem can act as an antifeedant. And that basically, it affects the digestive system, it affects the enzymes, the digestive enzymes in insects, and reduces the demand for food in insects. And that's why it is called an antifeedant. When it comes to toxicity, these botanical pesticides basically act on the nervous system of the insects. Basically, the channels and receptors of the nervous system, like the ACH enzyme, which acts as a receptor for the nervous impulses in the insect, they get inhibited by the botanical pesticides. Now, the botanical pesticides, the advantage here is that a single source of botanical pesticide can contain many secondary metabolites. It can contain an alkaloid, it can contain a phenolic, it can contain a monoterpene. And that's why, because of the synergistic effect of these secondary metabolites, the pest does not develop resistance. Because there are so many different types of secondary metabolites which are acting to protect the plant, the pest resistance is very difficult to develop to botanical pesticides, which is a problem which is seen with synthetic or chemical pesticides. And when it comes to insect growth regulation, the botanical pesticides act by controlling the reproduction, the growth, and the metamorphosis of insects. And they control it in 2 ways. One, by controlling, as I said, the reproduction, they control the number of eggs the insect can lay. They can control the female fertility. It can control the weight of the insects. Now, when it comes to growth, it affects the endocrine system. So the hormonal regulation in the insects can be modified or regulated by botanical pesticides. And so, let's say, for instance, azadirachtin. Azadirachtin can form juvenile hormone analogs, which can disrupt the endocrine system of the insect. Now, why does the one of the advantages is that the insect will not develop a pest resistance, because these juvenile hormone analogs mimic the insect hormones. This is one big advantage of the botanical pesticide, which is basically leads back to one of the benefits, which says that you do not have insect resistance or pest resistance or resurgence. Now, having described the the composition and the mode of action, I would like to briefly spend some time on the global scenario for botanical pesticides. So here, basically, I have shown what are the different products which are available commercially across the world. So here we have the details have been provided in terms of the botanical name, plant family, bioactive molecule, secondary metabolites, class, chemical structure, biological effect, product and trade name. So we can see that a large number of products are already available commercially in the world. So you have products like capsicum oleoresin, which in which the bioactive molecule is capsaicin, and the metabolite class is polyphenolic amide. You have cinnamaldehyde, which again is the metabolite is phenyl propanide. Then we have cinnamon essential oil, which is again the class is phenyl propanide. Similarly, you have clove essential oil, which has the bioactive molecule eugenol. Then you have, I have given the trade names which are already available in the market, globally. Then you have extract of giant knotwood, which the bioactive molecule is physiocion and amodin, which is again the metabolite is polyphenols, which are natural anthraquinones. Then you have jojoba essential oils, which contain straight chain wax esters, and the metabolite structure is lipids. I don't think it's very visible, but it's a sort of a lipid structure. Then Carangan, all of us are familiar with Carangan, which is derived from the Pongamia plant. And again, the molecule is, the bioactive molecule is Carangan, and its structure is, the class is flavonoid. And we have lemongrass oil, which is from the plant Symbopogon, and then the bioactive is citronal and citral, and it's basically a monoterpene. Then we have neem extracts, which all of us are familiar with the bioactive molecules being azadirachtin, nimbin, salicylic, and this falls in the class of triterpenoids. Nicotine is basically the bioactive molecule is nicotine sulfate, and this is in the class of alkaloids. We have phenyl propionate, which is a substituted benzene structure, which comes from the peperita, which is peppermint oil. Poppy extracts, which are alkaloids again, and pyrethrum. Pyrethrum is basically the largest selling botanical pesticide in the world. 80% of the market of botanical pesticide is pyrethrum. And these are basically the bioactive molecules of pyrethrins, cinerins, and jasmolins, and these are terpenoids. Rosemary essential oil, again a terpenoids. Rotenone is an isoflavonoid. We have rhinia, which is an alkaloid. And these are all, I've given the trade names of the products which are available in the global market. Sabadilla, which is an alkaloid, again, which acts as an insecticide. Thymine is an essential oil, which is a monoterpenoid phenol. Garlic extracts, allicin and diallyl sulfides act as insecticides. And finally, datura, which is again an alkaloid. So this basically gives you a flavor of what are the different kinds of products which are available in the market globally, and which shows that botanical pesticides are already gaining acceptance worldwide. But what is the scenario in India? The scenario in India is that botanical pesticides have to be registered in the schedule of the Insecticides Act. And the material that I've been presenting here is basically from a presentation by Mr. Subhash Chand, who was earlier the Deputy Director of Central Insecticides Board Registration Committee. And here, the botanical pesticides which are listed in India in the schedule are basically 6, which are pyrethrum, carangan, herbal extract, which includes diallyl sulfide, allyl propyl disulfide, neem-based pesticides, Symbopogon extracts, and eucalyptus extract. So this brings us to the question that while we have 6 botanical pesticides or pesticides of plant origin which are in the Insecticides Act, we have so many more worldwide. So, we do not have clove oil, we don't have jojoba essential oil, we don't have peppermint oil, we don't have datura, so we don't have nicotine. So clearly, I feel that there is a need to expand the list of botanical pesticides which are listed in the Insecticide Act, so that we can have more such botanical pesticides in the Indian market. And coming to the registration process, the process is basically the same as that for synthetic pesticides. The provisional registration can be done under Section 9(3)(b) for 2 years, and then subsequently regular registration under Section 9(3), and Me Too registration under Section 9(4). And for introducing any product which is a formulation based on one of the 6 botanical pesticides, we need to submit data under the 4 categories of chemistry, bioefficacy, toxicity, packaging, and labeling. And the data requirements listed in the presentation were basically mentioned for neem-based pesticides, but presumably they also apply for all pesticides of plant origin. And the specific data requirements are under each of these categories are listed here. The only point I would like to make here is that the toxicity studies which are listed for botanicals are the same as those for synthetic pesticides. And that's really one needs to ask the question as to, because botanical pesticides are generally more safer and less toxic, that do we need to really have the same stringent toxicity studies that we have for synthetic and chemical pesticides? Because they act as a deterrent for introduction of many new botanical pesticides. Now, I have talked about the benefits of botanicals, the advantages they offer, and how they can become a viable alternative to synthetic and chemical pesticides. But we also need to take cognizance of the fact that there are many challenges with regard to their commercial acceptance. They are still a small share of the overall pesticide markets, and I've listed some of the challenges here. One is related to the availability of raw materials for the manufacture of botanical pesticides on a large scale. In many cases, the raw materials are not available. And because there is a lot of variation in the composition with respect to region and the season, there is also the challenge with respect to the difficulties in standardization and quality control. Botanicals have lower acute toxicity, and they also have the problem of faster degradability, especially if they're not stored properly. And because a large quantity of botanicals and raw materials have to be processed to produce any commercial quantity of botanical pesticides, there's a lot of production complexity involved in the extraction processes. And finally, the regulatory processes are the same as those for synthetics and for chemical pesticides, which is a fairly stringent, long-drawn process, and that acts as a deterrent to the introduction of botanicals. So, in this, knowing that these are the challenges to get better acceptance of these botanicals, obviously we need to do a lot more work. So, in the Indian context, I would like to make some suggestions. India has an advantage that India is native to Neem and Pongamia trees, and by some measure there are 25 million Neem trees and 9 million Pongamia trees. So obviously there's a strong case for increasing the area under cultivation of Neem and Pongamia, because there's a large demand for these botanical pesticides based on these raw materials, Neem and Karanjin. And obviously these programs can be taken up under agroforestry. Pyrethrum, as I mentioned, is about 80% of the market for botanicals in the world is for pyrethrum, which is not grown in India, which is not cultivated in India. The major countries are Kenya and Tanzania. And obviously, the cultivation of pyrethrum can be explored in India. And India obviously has a lot of natural materials or raw materials for production of essential oils, basically garlic, peppermint, lemongrass, clove. And these can be promoted as biopesticides in India. And CSR institutes which do R&D work on biobotanicals are focused mainly on medicinal and food applications. I'm not aware of any ICR institute which works on botanicals for biopesticides. We need to obviously do a lot more R&D work to develop technologies which can produce biopesticides, botanical pesticides from the raw materials at a commercial scale. We also, the use of nanotechnology for developing formulations which give higher shelf life is a very promising area. And as I had already mentioned, simplification of toxicity studies for ensuring that you don't have to go through a very lengthy process for establishing the toxicity profile of the biopesticides. That's something we need to do. And the farmers were traditionally used to use a lot of botanicals as biopesticides, but then there was a shift towards chemical pesticides because of the effectiveness and because of the cost, because they are cheap. But we need to actually reorient the farmers once again back to botanical pesticides. We need to create the same level of awareness. So this brings me to the end of my talk. I would like to conclude. These are the references. I would like to conclude by saying that basically I've talked about how botanical pesticides can offer an alternative to chemical pesticides. What is the global scenario for botanicals, and what is the Indian context? What is the Indian scenario for these pesticides, and what are the suggestions? What actions we need to take to increase the acceptance of these botanical pesticides? And I would like to thank you for listening to me. Thank you very much.